Chapter 8, Section 1 is completing the square. And so now they're going to give you, complete the square, they give you some easy ones to start with. And so if they ask you to solve that, you know that to get x alone, you just have to cancel the square. And so we're going to do that by square rooting both sides. But when you square root both sides, you have to take into account that this number could be positive or negative. And when you square it, it will be positive 45. So we want to put plus and minus. Whenever you square root, both sides left, the square and the square root cancel, and on the right we have root 45. And just like you've learned, simplify that just the same as always. So I can see I have 2 3s, so that will come out, and I have 1 5, so it will stay inside the square root, and that is what x equals. Let's try this one. Suppose I gave you 5x squared minus 55 equals 0. Now, to complete the square, I need to get the square alone. So I'm going to go ahead and add 55 to both sides. And I'm even going to go further and divide by 5. So I'm going to divide both sides by 5. So I get x squared equals 11. Now I'm going to cancel the square with a square root, and since I'm square rooting both sides of an equal sign, I add plus or minus. On the right, we get plus or minus root 11. Now, this is starting to lead into what will look more like completing the square. But now we have a whole binomial. But once again, just this entire binomial is a perfect square. So I can do it just the same. I can cancel the square by square rooting both sides as long as I don't forget my plus or minus on one of those sides. And by the way, we typically put the plus or minus on the side that does not contain the variable. So you just have to put it on one side, and it's typically not where the variable is. And the reason being is, look right here, the square and the square root cancel. So I have plus or minus, and do you remember the square root of I? And then we just get x alone, just like always. So I'm going to add 1 to both sides, and then I'm going to divide by 3. And I should have wrote that 1 first, because they typically write the real number first and the imaginary number second. And that's all divided by 3. So it could look like that, or it could look like this. And these are... Now here's what most of your homework will look like. It will say something like this. X squared plus 8x equals 1. Now I have a perfect square, but if I get that alone, I'll have an x in my answer. And I don't want that. I need to get x alone. My whole point is to isolate x. So this x. So what we need to do is we need to make this factor into a perfect square binomial like we had here. But I can see right now I could factor an x out, but that would still leave an x in my parentheses, and so that would not give me a perfect square. So this is what we have to do. What we need to do is I'm going to leave a space to add a number that will make this a trinomial right there, that will factor if we want this problem to look like this one. So what number would I add right there? I usually let my class try and figure that out and see if they can come up with it. But here's the secret, so that you can figure out what number to add right here, so that it will factor into a perfect square. You always take half of the coefficient of x and then square it. So you might want to put that in your notes. Half of the coefficient of x and then square that number. So let's try that. If I take half of 8, I get 4. And then squaring that, I get 16. So 16 is the magic number that I have to add. But I know I can't just throw a 16 into an equation. I have to make it legal. So I'm going to add it to this side too. Now I've done it to both sides of my equal sign, so I have, and in your notes, you might want to stick that in a box so you remember that you inserted it into x times x is x squared, 4 times 4 is 16, and adds up to 8 in the middle. So, aha, I have a perfect square binomial. And on the right, I have 1 plus 16, which is 17. So, now I'm back to what I started with up here. I can cancel the square if I just square root both sides, and I have to remember a plus or minus. So, the square and the square root cancel, and on the right, I have plus or minus root 17. Now, x is almost alone. To get it completely alone, I need to subtract 4 from both sides. And so that is my final answer. 4 plus or minus root 17. Alright, let's try another one. Let's try this one. Alright, now, the only problem we did just started with x squared. Factor into something times itself with a 2 there, and it won't. In fact, it's really hard to complete the square with a factor there. So whenever you see a number in front of x squared, you're going to begin by dividing every single term by that number to just eliminate it. And as long as you do it to every term on both sides of the equal sign, it's legal. It's still an equivalent equation. So the 2's cancel there, and I have there, and I just have 1x. And then right here, I have 7/2. Now, if this would factor into a perfect square like this, I would just leave that 7/2. But that's not the number I want. So I'm going to take it to the other side, and I'm going to leave a space for the number that I do want. So it becomes negative. I subtract it from both sides. Now this one's kind of mean. Up here we just took half of 8 and squared it, and it was a nice whole number. But this one is 1. There's a 1 right there, isn't it? So half of 1 is 1/2. And 1/2 squared is 1/4. So that's my magic number. I have to add a 4th to both sides of this equation. So maybe I'll stick it in a rectangle so I remember that should factor into something times its perfect square. Now I know that my signs are subtract, so I have x subtract and x subtract because of that, right? So what times what is 1/4 and adds up to -1. And it's a half. By the way, it's always the number before you squared it. So, right there it is. It's always this number before you squared it. That's always, like this one, if I take half of 8, I have a 4 right there and there. If I take half of 1, I have a half right there and right there. And look, last times the last will be 1/4, and outside a half plus a -1/2 plus -1/2 will be -1. So it works. Now, I have to add 2 fractions, so don't forget I need a common denominator. So I'm going to times the bottom by 2 and the top by 2, so that I get -14/4 plus 1/4. Then I can combine 14/4, don't I? Alright, so now I can square root both sides. And don't forget your plus or minus, that's big. So I'm going to bring this up here where I have a little more room. So I have x minus 1/2 because the square and the square root cancel. Equals, and I have this, my plus or minus, and I can simplify that a little bit. I know that the 13 will be stuck inside, but the square root and the square root of the 4 is 2, isn't it? So that looks a little different, but that's the same term, and add 1/2 to the other side. So that is my final answer. And that, I can't remember the way my math lab will write it, but they are equivalent, aren't they? Alright, that's kind of a tricky section. If you have trouble on that, send me a question. When you ask it through my math lab, it sends me your problem, and I can just work it and post it in a page to give you a help. Good luck, you guys.